Hearing your description about this architecture, we can totally sense that it's really quite complicated. It's a cross-cutting thing. You need to find the right trade-offs based on the business requirements and also a few other quality attributes that sometimes people don't think about. But when it happened that the system doesn't scale or doesn't perform well, actually they will look back and see, okay, why didn't we think about it? Which brings us to these two quality attributes that I think is kind of like put as the major quality attributes. Two of them will be covered today, which is security and resilience. So the book mentioned actually that security is an architectural concern. I mean, we all know the things about security these days, especially a lot of vulnerabilities, a lot of major cases happen because of security. Why do you think it should be part of the architectural concern from the beginning?
Yes, good question. I mean, we sort of touched on it before. It's easy to view security as something that every part of your overall team, say you're structured around services, every service team will look after its architecture. The problem is that security is one of those, in my humble opinion, of course, being a security guy, I would say this, but it's one of the most difficult and one of the most critical. It's one of those that it's very hard to know if you are secure. One very small mistake can suddenly make you dramatically insecure. Whereas performance, I'd argue, it's easier to test that you've got acceptable performance, and performance tends to degrade. You tend not to go off a cliff. Now, I know there are exceptions. You can absolutely take the performance of a system off a cliff, but I think it's more common, in my experience, that performance degrades, and so you can address it while it's going on. Security, honestly, by the time you've got a disaster. So I think security is something that really has to be handled at system level. I'm not suggesting one person should do it. Don't get me wrong, that would be a terrible idea. But it's got to be thought of as a system quality rather than a quality that any one team in the system development organization can just do, either for themselves or everyone else.
And speaking about all these recent changes in the technology, like cloud, for example, the prevalence of cloud technology is now putting people's workload into a new territory. Let's talk it this way, because you might need to expose it over the internet. So previously you have only data centers, for example. So what other things actually has changed recently that makes this security landscape becoming more and more risky?
There's a couple of factors, both internal and external. The key external one is that the threat landscape in the security jargon has never been worse or more dangerous. There's a couple of reasons for that. Firstly, as you point out, most systems today are inherently embrace the internet. We went through three phases. Systems in their data centers, all safe and sound, very little connectivity. Then we had systems in their data centers, safe and sound, with very clear connections to the internet. And now we've moved to coin a phrase, the internet is the system era, where actually the internet just pervades the system. So different bits of the same system are connected across the internet. Public visibility is just now a given. And the problem with that, of course, is while it's very convenient, it means that you can access your system from anywhere else. So you can be attacked from anywhere. Whereas before, actually, it was quite hard for someone in, so should we say, North Korea to attack someone in Germany. Now it's almost trivial. Second thing is in the threat landscape. The thing that I often get extremely concerned about is how quite sophisticated attacks, quite sophisticated threats are being weaponized, as they call it, meaning packaged up. Again, 10, 15 years ago when I was first working in security, it's not that there weren't people out there who could exploit very subtle vulnerabilities. I mean, back then with compiled languages, stack smashing, for example, was something that there were lots and lots of people out there could do it. But actually, when I say lots and lots, it was a small community of very skilled people who probably all went to the same security conferences could actually do it. What's happened more recently is that it's become very much the norm that common and sophisticated attacks get packaged up into point-and-click tools and sold on the dark web for Bitcoin. That means that people with relatively modest amounts of money and some time can actually buy the expertise to do the attacks and just do them themselves. For example, botnets. Again, to build a botnet is a real non-trivial task. It requires real skill. But if you can rent somebody else's, that requires almost no skill. So the threat landscape's become really serious. And then on our side, as we've said several times, systems are now hung on the internet. We also tend to expose self-describing interfaces. I mean, I'm old enough to have worked not exactly on mainframes, but alongside mainframes. Back in those days, if you didn't have the protocol description, it was extremely difficult to actually interact with anything. And then these were huge, big, thick books, and you had to just go away and learn them. And whereas now we stick $JSON on the end of the URL, it tells you all about itself and says, here's how to attack me. And then the third thing is people are often today using security services, for example, authentication, authorization, distributed automatic protection of their data at rest and all of that. Actually, I think that's a really good thing because it's much, much better than building your own. The complexity for a team, though, is that by the time they've got something from a cloud manufacturer, something from a SaaS service, something from their database provider, and something from their application server, there's quite a complex web of pieces that they probably don't understand very deeply because they're not security engineers. This isn't what they do. They've got to put that together safely. Again, there were only a certain number of people who could actually put the security stuff together, and they were real experts. They were security engineers. And that in itself was actually quite a big problem because it slowed us down a lot. It made security engineers probably too powerful and often limited what we could do. Or people just went ahead with almost no security because they didn't have a security engineer. Today, all the bits you need are there. You probably don't need a dedicated security engineer. But on the other hand, if you actually don't understand all the pieces, you could create a very insecure system and very secure services. So that's, I think, why people just need to be much more aware today than they were of the security in their systems from the first time they write a line of code. Because again, historically, there's always been a tendency for security engineering to look at the requirements, give some broad recommendations, a few sketch choices about how things might work and go away, and then come back quite a long time later when quite a lot had been developed and tell everyone it was wrong, and here's what they had to change to put the security in. So the security sort of all bolted on late on. Well, because we ship stuff now almost immediately into public-facing clouds, we just can't do that anymore. So almost as soon as we're writing a line of code, we need to be thinking about how do we make sure that it's a secure line of code, and it will be deployed and operated securely as well.
So thanks for sharing all these different aspects. Definitely, I learned a lot of things as well. For example, exposing yourself unnecessarily through self-describing interface. I didn't really realize that, but yeah, actually that's true. And the other things is complexities of different multiple technologies that we are integrating now, like we mentioned, authorization, authentication as a service, even managed services from the cloud or platform as a service. So all those things, we need to know different permutations of how they actually interact and basically find the loopholes where the security danger is. Thanks for sharing that.